For our 13.2 Part 1 notes, we are going to be discussing what volume is and how we identify the volume of a rectangular prism. So volume is different than surface area. So surface area is when we took that shape and we were just finding the flat surfaces. So we could unfold it and make it a flat shape. So it was still just one, right? It was two-dimensional. We had the length and we had the width. It was flat. Okay, right? Like a piece of paper. We could just take that paper, we have the length, we have the width of it. So, right, we can make different shapes with the paper, but we can fold that paper flat. When we're talking volume, we're talking how much space does it take up? What can fit inside of that shape? So when we're talking volume, the amount of space an object takes up. So we have to calculate 3 dimensions to get volume. We can't unfold it flat. It's always got to take up 3 dimensions. So to find a rectangular prism, like you learned in your hands-on experiment, you have to find the length, and then you times that by the width that goes back, and then by the height. You have to have all 3 dimensions to make a 3D object. So when we are labeling that, you are going to label it units, and then you are going to label it cubed. So instead of squared, like we have been doing, because we were doing 2 dimensions, length times width, but now we're doing 3. We're making a 3D object now. You need the length, the width, and the height to say. So now we're saying how many cubes fit inside another shape. We're saying, right, how many little cubes can fit inside of that rectangle. So it's a 3D cube, the length, the width, the height, how many cubes fit inside of this. So when we have a 2, that means squared. When we have a 3, that means cubed. So it's units to the 3rd, or, oops, it's still typing in my little tiny text. Let me take that off, or units cubed. Okay, you can write it out either way. So I imagine most of you will want to take the shorter way and just put that 3 there to show it's cubed. But that's how we differentiate. This is volume versus this is area or surface area. So we've got to get that label on there to show that this is volume. This is the space it's taking up. This is what can fit inside of here. So let's take a look at this problem here. So how does the base of this rectangle, so here's our base, so we've used that word a lot, right? The bottom of it, relate to the volume. So we're just taking this base, that same shape, and this base is, it goes 5 over, so to get a base, we take base and height, length and width, and that makes this bottom shape. Length times width equals the base. So when we do length times width, that equals the base or the bottom of the shape. And then we're just repeating that base over and over again on a rectangular prism. And then, right, then we want to, once we know the base, we just repeat the base. So let's take a look at this one, right? So this one went over 5, back 2, so we have a total of 10 as our base. The base is 10, length times width is 10. And then we are repeating that 1, 2, 3 times. So there's 10 on this level, 10 on this level, 10 on this level, right? 3 layers of 10 makes 30. So we could solve this and we could do 5 times 2 times 3. 5 times 2 is 10, times 3 is 30. Or we could do, so right, this is length times width times height is the volume. So there's one way to do it. Or we could do the base times the height equals the volume. So the base of this is 10 times the height is 3 levels equals 30. So you have to pay attention, right? We've done a base before, but it was one thing. When we're finding the base of a 3D object, that means we had to multiply. So the base of a 3D object just means the bottom of it. That's different than, right, the base of a triangle, but it means the same thing, right? The bottom of the triangle, the bottom of this three-dimensional shape. So you might see sometimes they might already give you the base of the rectangle. They might say the base of this is 20. You have 5 levels of that. What is the volume? They've already multiplied the length and the width for you. How nice of them. You just have to see how many levels of that you have. Or if it gives you all 3 dimensions, length times width times height. And we could mix these up. We could use the commutative property, and I could do 3 times 2 is 6. I could say, right, I have going this way. There's 1, 2, 3, 4, 5, 6. Or I guess I counted this side. 1, 2, 3, 4, 5, 6. There's 6 right here. 6, 12, 18, 24, 30. I can use the commutative property. I'm going to get the same thing. I'm finding one section and I'm repeating that over and over again. Oh, but I do need to get my label. So these were centimeters cubed. So however I choose to do it, I do need that label to show that it is volume. So whether I do length times width times height, or if it gives me the base and I find the length times width, right? The base is length times width, and I times it by the height. It's always going to be 3 dimensions because it's taking up space. What goes inside of it has to be cubed.